If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in hyperbola. So today again we will see what do you mean by conjugate hyperbola, and we will make some key points on this conjugate hyperbola and rectangular hyperbola. Okay, then let's see this. Okay, the next article is conjugate hyperbola. If you have given this hyperbola, this one, whose TA is in x-axis, suppose this is my hyperbola, so its TA is in x-axis, CA is in y-axis. Now the hyperbola whose TA will be in y-axis, same. Now this is a hyperbola whose transverse axis become the conjugate axis of the earlier one. So it conjugate axis, this is becomes its transverse axis in y-axis. So and its transverse axis becomes its conjugate axis in x-axis. That is known as rectangular. So this is the original hyperbola. This is its conjugate hyperbola, sorry, not rectangular, conjugate hyperbola. This is original, this is conjugate. So its transverse axis becomes conjugate axis for the another one, and its conjugate axis becomes transverse axis of the another one. Just changes their positions. That is known as conjugate hyperbola of the given hyperbola. So the conjugate hyperbola is nothing but y minus b square minus x minus a square is equal to 1. B and a interchange. That is minus is interchange. Then it's, we know then in this case this transverse axis will become 2b, which is its conjugate axis. So this one you can write it by multiplying minus x square by a square. There is a square, you put it there. X square by a square minus y square by b square is minus 1. So you can directly write, if this is my original hyperbola, then conjugate hyperbola is this one, just a minus 7. Suppose the eccentricity of this one is this, then is E dash is the eccentricity of this. So what is eccentricity of this is, that means b square is equal to this one, we have seen. And here a square is equal to b square into this one. So if you take product of these two, e square minus 1 and e dash square minus 1, then it is b square by a square into a square by, that is 1. If you divide both sides by e square, e dash square, then you will come to this. If you open it, then you will come to a conclusion this. So if they are conjugate hyperbola, this relation always satisfies. 1 by e square, 1 by e dash square, this is of 1, this is of that conjugate one's eccentricity. So if you do this one, 1 by this square, 1 by that square will be equal to 1, sum of these two. And from here one more observation that we will be doing in key points analysis. You can see a square is equal to b square plus a square, and b square e dash square is nothing but also a square plus b square. Now what is a square in original one? A square is the distance of the focus. What is b square, b e dash? What is AE? AE is the distance between focus. What is b e dash? Is this point 0 comma b e dash. That is the focus distance. So both that is also focus here. Sorry, here. So the focus are equidistances. So this focus and this focus, they are at same distance for original hyperbola and conjugate hyperbola. So the foci of the hyperbola and its conjugate are concyclic from the vertices of and form the vertices of the square. They are concyclic means they are at equal distance, so you can draw a circle with these 4 points, because this will be also radius, this will be radius, because both these lengths are equal to a square under root a square plus b square, and they form a vertices of a square also. If you join this, they will form a vertices of a square also. Two hyperbola are said to be similar if they have same eccentricity. If we have any two hyperbola whose eccentricities are same, then we can say that they are of same eccentricity, same hyperbola. Length of retrosectum of rectangular hyperbola, 2b square by a, b is here a rectangular hyperbola, the earlier one, not this one. I am making a key points of all this from rectangular and conjugative both. So it is equal to 2a, which is length of TA or CA, because in case of rectangular both are same. Transverse axis, conjugate axis. If a hyperbola is equilateral, then conjugate hyperbola is also equilateral. If your original hyperbola is equilateral, that is rectangular hyperbola, then its conjugate will also be rectangular or equilateral, because both are same, that's why. Asymptotes are the tangents to the hyperbola from the center. So what are the asymptotes? Asymptotes are the tangents that you are drawing from the hyperbola from the center. So if you have a center, if you draw tangents which touches at that point infinity, that becomes your asymptotes. So that is a very good observation. Asymptotes, we can also say it is a tangent to the hyperbola from the center. If you draw a tangent from the hyperbola, it will touch at infinity, that is nothing but your asymptotes. In case of rectangular hyperbola, the perpendicular tangents are drawn from the center of the hyperbola. That we have seen this one here. You remember diameter circle, when discussing diameter circle, we discussed if v square equal to a square, then radius becomes 0 point circle. That means you can only draw tangents from a point that is 0, 0, because your circle becomes a point here. This becomes a point here. So you can draw perpendicular tangents only from the center. if your b square equal to a square. If b square is equal to a square, then it becomes a rectangular hyperbola. So in case of rectangular hyperbola a equal to b, your perpendicular tangents, you can draw only one set of perpendicular tangents, and that can be only from this. This is also rectangular hyperbola. This is from the original x-axis and y-axis. These are at 90 degree. Or you can think it in this way also, this and this. So these are at an angle of 90 degree. If it is rectangular, then you can draw two perpendicular tangents from the origin, only from the origin, and the tangents drawn from the origin is nothing but asymptotes. So they become asymptotes also. If you like the video, then press the like button and please give your valuable comments in the comment section.